Hi students, welcome back to my channel Ultrasound Whispers. Today we will discuss acoustic parameters and acoustic variables and the difference between acoustic parameters and acoustic variables. Let's start our topic and hopefully you will enjoy it. We will also do some review. Uh, Ultrasound waves, these three parameters rhythmically changes. That is why these are called sound waves. And sound waves, these acoustic variables, I already told you that acoustic is derived from a Greek word that means hearing, and variable means that changes. So these acoustic variables, pressure, density, and particle movement are actually the introduction of the sound wave. And no sound wave can be called a sound wave without these variables. So it is the introduction of the sound waves, and these are the hallmark of ultrasound waves. There are seven acoustic parameters of sound waves, and acoustic again mean regarding with the sound waves, and parameters are the features that are specific to the sound waves. And there are seven parameters, and we already have discussed most of them, and these are time period, wavelength, frequency, and speed of the sound waves. These four parameters we have already discussed. Today we will discuss three new parameters that are called amplitude, power, and intensity. We are familiar with the amplitude, and these two terms are new. And amplitude and power and intensity actually are interrelated. And when the amplitude of a wave increases, amplitude is the distance from the maximum point of the crust to the zero line. This is zero line. So when amplitude increases, power and intensity also increases. Power and intensities are actually the energy, and we will discuss a little bit later in coming slides. And later three, amplitude, power, and intensity, are also called the bigness of the ultrasound wave. Bigness means the magnitude or the strength of the ultrasound waves. So these three parameters that I have written in red are interrelated, and they define the bigness. Bigness means loudness, strength, magnitude, or height of a wave, sound waves. And these are interrelated, and any change in an amplitude will automatically increase power and intensity, and any decrease in amplitude will decrease power and intensity. So these are the seven parameters of ultrasound waves. And to memorize these parameters, you will have to switch to our favorite favorite cycle. And time period, time to complete one cycle is called time period. Time to complete one cycle is called time period. And if the cycle is large, so this is a large cycle, it will take more time to complete this cycle, so time period will be increased. And time period is represented in second, millisecond, and microsecond. And time period is directly related to the wavelength, and we will discuss that how they are interrelated. And time period is a reciprocal of the frequency, so you need to remember this relationship. And let's discuss how these. So as far as wavelength is concerned, wavelength has a different definition. We discussed it, we already discussed it, that wavelength is the distance. Wavelength is the distance, and if you see the wavelength, actually name indicates that length of the wave. And length of the wave starts from here, from this point, and ends at this point. This is the end point. So the distance covered by a wave from start of the cycle to the end of the same cycle is called wavelength, and it is represented by a Greek letter lambda. Or you can also define this, that a distance from the start of a cycle to the start of a new cycle. This is the area where new cycle is gonna start. So this definition is almost the same. There is just a change of the words. And when we have a pulse, so for pulse, we know that these area of compressions are called crust. The distance between the two consecutive crusts is called wavelength, and these valleys represents the area of rarefaction, and the distance between two consecutive trough is called wavelength. And wavelength has inverse relationship with the frequency. When wavelength increases, frequency decreases, and vice versa. So, and we earlier discussed that that time period is directly related with the wavelength. When wavelength increases, it will increase the size of the cycle. And when the size of the cycle is increased, it will take more time to complete that cycle. So by increasing wavelength, time period is automatically increased. So there is a direct relationship between wavelength and time period. If wavelength decreases, decreased wavelength means a small wave. And small wave will take less time to be completed, so the time period is also decreased. And we know that wavelength and time period are equal, so you can replace wavelength with the time period. Now the time period and frequency have inverse relationship. When you will increase the time period, or in other words, you will increase the wavelength, you are increasing the size of the wave, and you are increasing the time period, and you are decreasing the frequency. Fourth parameter that we already discussed is the propagation speed. Propagation means traveling, that at what rate it travels. If a pulse, a distance covered by a wave in 1 second, is called the distance traveled by a wave in 1 second is called its speed. If more distance is covered in 1 second, we can say that the speed is increased. So in order to understand, again, I will that in order to understand and memorize these acoustic parameter, you need to understand this cycle. And we also know that the amplitude is the distance from the highest point of the crust from a zero line. This is your zero line, or the distance between the highest point of the trough from the zero line. So when amplitude is increased, see, it's large amplitude, and amplitude is increased, it's called positive amplitude, and this is called negative amplitude. When amplitude increase, you see there is a marked difference between the height of these two waves. If we say that it's a wave 1 and it's a wave 2, so wave 2 is higher than wave 1, and amplitude is actually the highest point, represents the highest point of the pressure and density. So when amplitude increases, automatically it will increase its power, it will increase its intensity. We will discuss this relationship and this concept in coming lectures and in coming slides. Let's move forward. So these were the parameters. So what is the difference between a cycle and a inverted cycle? So suppose here is a cycle. Let me make it different. Suppose this is a cycle. This is the area of compression. And this is the area of rarefaction. One compression and one rarefaction is called one cycle. And if you flip this cycle like this, now this cycle is starting with crust and ending with, sorry, here is a trough, is trough. So when you will flip and cycle start from a trough and end with crust, so this is trough and this is crust. So this cycle is flipped. Now it is called inverted cycle. And when a pulse is reflected from the boundary of the soft tissue, it is inverted. Did you notice the inversion? This pulse is starting with crust, but this is starting with trough. This is pulse. Sorry, this is echo, because it is the reflection of this pulse. And this is pulse. Pulse is going this way, echo is coming back. So this is called the inversion of the pulse or inversions of the cycle. So cycle starting with the crust ending on the trough, and the cycle that's starting with the trough and ending at the crust. It is just like, suppose we have a train. And it has an engine. And it makes a round trip between A and B. When it returns from the point B, now its engine is flipped. And also make wheels of the train, because without wheels a train cannot move. And sorry for my awful drawing. So this is called the flipping of the pulse or inversion of the pulse, and it usually occurs when the pulse come back after reflecting from internal organs. Continuous waves. In order to explain continuous waves, so there are some transducers that are used in ultrasound field that are called continuous wave transducer, and they continuously produce sounds. Usually they have two crystals, and other crystal continuously receive echoes, and there is no listening time or there is no resting time. So they do not make imaging, and they are used to determine to calculate the high velocities, especially in cardiovascular ultrasound. We will discuss it later. So for now you need to remember that there are two types of transducer. One are the continuous wave transducer, and other are the pulse wave transducers. Pulse wave transducer are those that produces ultrasound waves in the form of pulses. Pulses of 2 or 3. When a transducer produces a pulse, then it becomes silent. It does not produce any pulse until and unless it receives echo of this pulse. This is echo. And once it receives echo, it sends another pulse. So the period when the transducer is silent, it producing no pulses, is called its off time or listening time. In this listening time, it receives echoes and convert into image. So in continuous wave, there is no listening time, there is no break, and the transducer is continuously talking. So they cannot produce image, and only the transducer that send ultrasound waves in the form of pulses, and they have listening times or off time, they can produce images. So example of continuous waves, there is no break, and now we will discuss between the difference between pulse frequency and pulse repetition frequency. So this is a pulse, and the distance between two consecutive crust or two consecutive trough is called wavelength. And we also know that wavelength and frequency have inverse relationship. So when you increase the wavelength, frequency will decrease, and when you will decrease the wavelength, frequency will increase. This is called the frequency of the pulse. So what is pulse repetition frequency? Pulse repetition frequency is very easy. Suppose here is a transducer and it produces a 2-cycle pulse, and after 1 second it repeats its process and again produces a pulse. So after every second, this transducer is producing one pulse. So the frequency will be 1 hertz. So number of pulses produced each second is called pulse repetition frequency. And most of the time you will encounter this term pulse repetition frequency, and it is represented by PRP, pulse repetition frequency, that how often a transducer repeats its pulses and how many pulses it repeats. For example, it repeats 2 million pulses in 1 second. After every second, it produces 2 million pulses. So its frequency will be 2 megahertz. So 2 megahertz will be the pulse repetition frequency. And it is different from the frequency of the pulse. We discussed time period. Time to complete 1 cycle is called time period, and frequency is a cycle per second. We discussed it number of time, and it has inverse relationship with wavelength. So in imaging ultrasound, our imaging transducers probes produce group of cycles, group of 2 cycles, 3 cycles, 4 cycles. So one cycle is a wave and 2 cycles are a pulse. One cycle, another cycle, and it will give you a pulse. And in diagnostic imaging, there are a group of cycles, group of 2, 3, or 4. Wavelength is the distance. We discussed it in detail, that the distance from the start of a cycle to the end of the cycle, or start of the cycle to the start of the new cycle, or the distance occupied by a cycle. And suppose we have a cycle here and we have second cycle here. This is a small cycle and it's occupying less space, while cycle number 1 is occupying more space. So it's a large cycle. The space occupied by a cycle is called wavelength. Wavelength and frequencies are inverse relationship, and in this image you are seeing 2 waves, and if you notice the wavelength, pulse number 1, this is pulse number 1, and it has a small wavelength as compared to the pulse number 2. This is pulse number 2. There is a larger distance between 2 consecutive crusts, and there is a smaller distance between 2 consecutive crusts. So the difference between the acoustic variables and acoustic parameters is that acoustic variables are actually the changes that are related with the medium, changes related with the medium, while parameters are the characteristics, are the features that are related to the ultrasound waves. One is related with the waves and other is related with the medium. So this is the difference between acoustic variable and acoustic parameter. Acoustic variables are the introduction of ultrasound waves, and acoustic parameter are the characteristics, feature a sound wave holds. And an acoustic variable, we discussed before that there are pressure, density, and movement, particle of the movement, and some people also include temperature as the fourth parameter, fourth acoustic variable, but the temperature of the human body remains constant, so it has no significance on any characteristics of the sound wave. So magnitude, strength, and size of the sound wave, we discussed that there are 3 parameters that are amplitude, power, and intensity that represents this magnitude, strength, and size of the sound waves, and they are interrelated, and change in any entity will affect the other entities. And sonographer can easily control these 3 parameters by pressing some knobs on the console of ultrasound system. And we will discuss those knobs and their function in knobology when we discuss knowledge of ultrasound system. So amplitude decide what will be the amplitude of the wave. It is decided by the source, and it's a relative term, hence it is its units are described in decibels. So in this way, in this image, you are seeing uh, different waves of different amplitude. This is the highest amplitude, this is the medium one, and this is the smaller one. And it is actually the height of the wave. Height of the wave means the strength of the wave, the magnitude of the wave. So power is energy per unit area, and its units are watt, and it is determined by the source. What will be the power of the ultrasound waves? It is uh, decided by the ultrasound system, and a sonographer can change the power by pressing the knob on the ultrasound system. Intensity. So in order to intensity is related with the ultrasound beam. What is ultrasound beam? Suppose here is a transducer. Transducer sends number of pulses inside the body, millions of pulses, and these pulses all together make beam that is called ultrasound beam. And energy carried by this ultrasound beam is called intensity. And as we discussed before, that when sound wave travel through a medium has some effect on ultrasound. What is that effect? When these pulses will reflect, they will be weaker. Similarly, these sound waves have effect on the medium, and they have ability to deposit energy in the soft tissue. And when energy is deposited, and that energy can damage a soft tissue. Effect of sound waves on the medium is called is known as bioeffect, and we will discuss in detail when we will discuss the chapter of bioeffect. And for now, we don't have any known bioeffect related with the ultrasound waves, no side effects of ultrasound waves. So however, there are some recommendations that how the power and intensity should be minimum while scanning scanning a patient. Intensity is also represented in decibel, and a source decide what will be the intensity of the sound waves, and a sonographer can change this parameter. We discussed that power, amplitude, and intensity relationship are interrelated, and any change in one parameter can affect the other one. And to calculate the power, you need the amplitude and make it square. And if they give you the amplitude and ask you what is the power, so you will take the square of amplitude, it will be 4, and don't forget to write the units of the power that are watt. So amplitude square is equal to the power. So here is a chart what we can control and what we cannot control. So these three parameters, amplitude, power, and intensity, that can be controlled by a sonographer. Yes, we can control it. But there are some parameters like time period, wavelength, frequency, and speed. These parameters, we cannot control these parameters. So these parameters are decided by the source, but we can control it. And frequency, wavelength, and time period are also decided by the source, but we cannot control those. Let's talk about some few words about speed of the sound wave. So speed of the sound waves in soft tissue, remember in millimeters, is 1540 meter per second, and in millimeter microsecond it is 1.540 millimeter per microsecond. And never ever forget this value and these units. They are often used in solving different problems, and there are a couple of questions regarding with this in SPI board exam. Speed of sound in air is 330 meter per second, and speed in soft tissue, that are also called biological tissue, is 1540, and speed in the bone is 3500. And you will see that the speed of the sound in air is very low, and speed of the sound in bones or solid is very high, and there is an intermediate range. Why we have these three different speeds? Because we have three different media: air, soft tissue, and bone. So how we define a medium? A media. Medium is characterized by its stiffness and its density. So stiffness and density is actually the introduction of the medium, and stiffness and density of air is different from bones. Bone is more stiff, and when stiffness increases, the speed of the sound increases. So we will discuss in detail when we will discuss the medium and its characteristics. And the second most important thing, always remember units. In meter per second, speed of sound is 1540, but in millimeter micro per second, it is 1.54. Speed of sound in water is 1480. If you see that this number is close to this number, and this is speed in the soft tissue, and this is speed in the water. Why they are very close? Because soft tissue are mainly water. That is why speed in the water is almost equal to the speed in the soft tissue. Let me this forward, and we have already discussed that these two speeds are very close to each other. Elastic property of a medium. So these are two elastic property of the medium, stiffness and density. These are called the elastic properties of the medium, and they affect the speed of the sound waves. Thank you very much, and this is all for today, folks. Please subscribe my channel and like this video.